In this video, we're going to review the laws of exponents. And we're going to focus specifically on integer exponents, okay? So integer exponents, they are used for representing repeated multiplication of a number or an expression, okay? And we write them as superscripts, like in this expression, right? A here is what we call the base, and n is the exponent or the power. Okay? And we read this whole expression as a to the nth power, or a raised to the power of n, right? Where a is any real number, and n, for now, we'll focus on positive integers for the exponent n. Okay, later on, we'll also see what will happen if it becomes negative or 0. Okay, but again, for now, n, the exponent, must be a positive integer, right? Which means that it can be any natural number or counting number, because n represents the number of times we use the base as a factor in multiplication, okay? So if we say a to the nth power, then we have n a's as factors, okay? So here we have n factors. Okay, so we just count the number of factors, and that's the exponent. Okay, so for instance, a raised to the power of 1, so that would be a single a, right, as a factor. And then if we say a raised to the power of 2, or a squared, then that would be 2a's as factors. So a times a, right? If we have a to the third power, or a cubed, then that would be 3a's as factors. So a times a times a, and then a raised to the fourth power, for example, so that would be 4a's as factors. So a times a times a times a, right? And so on and so forth. Okay. Now let's take a look at some of the rules that we employ when dealing with exponential expressions. Okay, first one, this is what we call the product rule. Okay. This rule states that for any real number a, or any non-zero real number a, and positive integers for the exponents n and m, then the product of a raised to n and a raised to m is equal to a raised to the power of n plus m. Okay, this means that when we multiply expressions or exponential expressions of the same base, then we just copy the base and then take the sum of the exponents. Okay, so as you can see, again, this will only work if the base of the factors are, or the base of the expressions are, the same. Okay, so for example, we have here a squared multiplied by a cubed. Okay, so this is basically a raised to the power of 2 plus 3, so that's a raised to 5, right? But what actually happens is that we have here first factor. If we just consider the first factor, that would be 2a's, right, as factors. So a times a, and then we multiply this by another 3a's, so a times a times a, right? And then we just count the total number of a's, so 1, 2, 3, 4, 5. Okay, and that would be a raised to 5. Okay, so again, essentially, you just copy the base and then take the sum of the exponents, right? So let's say 2 squared times 2 cubed. Okay, this is obviously equivalent to 2 raised to the power of 5, right? But again, let's say 2 times 2, that's the first factor, right? 2 squared, so 2 2's as factors, and then multiply this by 3 2's. Okay, so 1, 2, and then 3. All right, so that would be 2 raised to 5. Okay, So next time you can skip these lines. Okay, you can just immediately proceed with the rule. Just copy the base and then take the sum of the exponents. Okay, and then if it involves constant values, then you evaluate further. Like this one, 2 raised to 5, that would be, so we say here 2 squared times 2 cubed is equal to 32. Okay, now what will happen if the exponent is a negative number? All right, so let's talk about negative exponents. But before we talk about negative exponents, let's first recall a raised to n, or a raised to the power of n, where n is a positive integer. Okay, so what actually happens here is that we multiply n factors of a by 1. All right, for any number or expression, we always have 1 as one of the factors. Okay, and it's because of its identity property, right? Any number or expression multiplied by 1 is the same number or expression. Okay, and for this one, we can rearrange this as 1 times n factors of a. Okay, now if the exponent is negative, like in the case of a raised to the power of negative n, then it indicates that we are taking away n factors of a. Okay, so essentially it means that we divide by n factors of a. All right, so instead of saying 1 times n factors of a, then here we say 1 divided by n factors of a, right? So in short, a raised to the power of negative n is equal to 1 divided by a raised to the power of n. Okay, or it's just the reciprocal of a raised to the power of n, right? So let's take a look at some simple examples. So we have here a raised to the power of negative 4, right? So this means, again, this means 1 divided by 4 factors of a. So a times a times a times a. Or in short, that would be 1 divided by a raised to 4. Okay, so there's no need to write this exponential expression in this form. You can directly write it in this form, right? So next we have, for example, if we put a constant value for a, so we have here 2 raised to the power of negative 4. So that would be 1 divided by 2 raised to 4. Okay, so that would be 1 divided by 16, right? Now let's apply the concept of negative exponents in the next rule, which is the quotient rule. Okay, this rule states that when dividing expressions of the same base, so again, the base in this case is a is any non-zero real number, and then our exponents are n and m, and they are positive integers. Okay, so again, this rule states that when dividing expressions of the same base, we just copy the base and then subtract the exponent in the denominator from the exponent in the numerator. Okay, and in short, so this is the rule. We have a quotient. Okay, so quotient, or we divide a raised to n by a raised to the power of m, and it's equivalent to a raised to the power of n minus m. So what happens here actually is that we have a raised to the power of n divided by a raised to the power of m, right? So let's just copy the numerator, a raised to n, okay? And then a raised to m here in the denominator can be written as a raised to negative m, right? From the negative exponent rule. Okay, so we multiply this by a raised to the power of negative m. Again, this is from the negative exponent rule. Okay, we now have a product of two exponential expressions with the same base. And then from the product rule, according to the product rule, if this is the case, then we just copy the base, right? So a, and then take the sum of the exponents. So the exponents are n and negative m. So we take the sum, that would be n plus negative m. So essentially that's n minus m, right? So this is now the quotient rule. Example, we have here 3 raised to the power of 7 divided by 3 raised to the power of 4. Okay. For now, let's do this the long way. Okay, I will not be directly applying the rule, so we can check if it truly works. All right. So here we have, on the numerator, we have 7 factors of 3. So that would be 1, 2, 3, 4, 5, 6, 7. Okay. And then on the denominator, we have 4 factors of 3. So that would be 1, 2, 3, and 4. All right. Now we have common factors, right? And if we have common factors, then we can cancel them out. So we have here 1, 2, 3, and then 4 common factors. Okay. We are now left with 3 times 3 times 3. Okay, as you can see here in the numerator. Or in short, that would be 3 cubed, right? And since it's a constant value, then we can evaluate further by saying 3 cubed, that would be 27, right? And as you can see, it agrees with the rule, okay? Because if we simply express 3 raised to the power of 7 and 3 raised to the power of 4, let's say, express this as 3 raised to the difference between 7 and 4, so that's 7 minus 4, and that would be 3 cubed, right? So again, it agrees with the quotient rule. So you can skip these lines, this one and this one, right? You can proceed directly to this line, okay? Then so on and so forth, all right? Next, let's try another one. So we have here 4 raised to the power of 6 divided by 4 raised to the power of 8. Here, the exponent in the denominator is greater than the exponent in the numerator. So we expect a negative number as the difference, right? So again, let's do this the long way. Let's see what will happen, okay? So we have 6 4s in the on the numerator. So 1, 2, 3, 4, 5, 6. And then on the denominator, we have 8 4s, 8 factors of 4. So 1, 2, 3, 4, 5, 6, 7, and 8. Okay, and then again, we cancel out common factors. All right. And so we are left with 1 divided by 4 times 4, or in short, that would be 1 divided by 4 squared, right? Or ultimately, that's 1 over 16, right? So again here, what happens if we directly apply the quotient rule? So let's do this from the top. We have here 4 raised to the power of 6 divided by 4 raised to the power of 8. Okay, so applying the rule, it says here we copy the base and then we subtract the exponent in the denominator from the exponent in the numerator. So 6 minus 8. Okay, and this will give us 4 raised to the power of negative 2. Okay, and then applying negative exponent rule, that would be 1 over 4 squared and then 1 over 16. Okay. Now let's talk about the zero exponent rule. Okay, this rule states that for any non-zero real number a, then if we have a raised to the power of 0, then it's equal to 1. Okay, so any number, any expression raised to the power of 0, it's always equal to 1. Okay, you might be wondering why this is the case. So let's see what actually happened here. Okay, so we have a raised to 0, right? Now we can express 0 as the difference between, or difference between a positive number and itself, or the same positive number. Okay, so we say, for example, a raised to, again, we can express 0 as the difference between a positive number and itself. So let's say n minus n. Okay, now applying quotient rule, we can write this as, so we apply quotient rule, so we have a raised to n divided by a raised to n, right? Again, this is from the quotient rule. And we now have a number, a raised to n, divided by itself. So this results to 1, right? Hence the rule. Okay, so let's have an example to make this clearer. Okay, we have here 9 raised to 0. And then let's say we express 0 as, let's say 2 minus 2. Okay, so 9 raised to 2 minus 2. 2 minus 2 is obviously 0. And then applying quotient rule, that would be 9 squared divided by 9 squared. Okay, so obviously 9 squared is the same as 9 squared. So if we take the quotient, then that would be equal to 1. Or we can go further by saying 9 squared is 81, right? So we say 81 divided by 81. Okay, the 81 divided by 81 is 1. Okay, so any non-zero real number raised to the power of 0 is always 1. All right, next we have the power rule. Okay, so for any non-zero real number a and positive integers for the exponents n and m, then if we have quantity a raised to the power of n and then raised to the power of m, then we just copy the base and then take the product of the exponents. Okay, so for example, we have here quantity a squared and then raised to the power of 3. So this means that we have 3 factors of a squared, where a squared is a times a. So we say a times a, so that's 1 factor of a squared, then times another a times a, right? And then lastly, another factor of a times a. Okay, so we just count the total number of a's. That would be 1, 2, 3, 4, 5, and 6. And so we say a squared, or quantity a squared raised to the power of 3 is a raised to the power of 6. Or in short, you just multiply 2 by 3. Okay, so you take the product of the exponents, right? So for example, 2 squared, or quantity 2 squared raised to the power of 3. Again, it means we have 3 factors of 2 squared. Okay, so we say 2 times 2 times 2 times 2 times 2 times 2, right? And it means 2 raised to the power of 6, right? Which is equal to 64, right? Or we can simplify first 2 squared, right? So let's say, for example, 2 squared raised to the power of 3. Okay, again, we simplify first 2 squared, so that would be 4, right? And then cubed. So 4 times 4 times 4, that would be 64 also, right? And then lastly, we have the distributive property, or we also call this the power of a product and power of a quotient. Okay, so basically, if we have a product between, for example, A and B, and they are raised to a certain power, in this case n, so we have your quantity A times B raised to the nth power, then we can distribute n. Okay, so this is equivalent to A raised to the power of n times A times B raised to the power of n. Okay, then power of a quotient. So if we have a quotient, A divided by B, and the whole expression is raised to the power of n, then we can also distribute the power. So it's equivalent to A raised to the power of n divided by B raised to the power of n. Okay? All right. So let's now work on some examples. Okay? So we have here some problems involving exponential expressions, and we are required to simplify them and express in positive exponents. Okay, so first one, we have here negative 28, and then a raised to the power of 6, b raised to the power of negative 3, c raised to the power of 5 all over 7 times a raised to the power of 11 times b raised to the power of negative 5 times c raised to the power of 5. Okay, so here we can, this contains constant values, so we can isolate those constant values and work on them separately. Okay, so we have here negative, so we can just simply say negative 28 divided by 7. Okay, and then we'll simplify this later, and then we'll also group together the variables with a, b, and c. Okay, so we have here a raised to what? So we have 6, and then applying quotient rule, so we have 6 minus 11. Okay, and then we have here b raised to negative 3. So again, we have a quotient, right? So let's apply quotient rule. B raised to negative 3 minus negative 5, right? If this is confusing, then you can also, I mean, before you simplify this one, this expression here involving b, you can convert them first to positive exponents by converting them into their reciprocals. Okay, and this is according to the negative exponent rule, right? So b raised to negative 3, that would be 1 over b raised to 3, right? So let's say we isolate b raised to negative 3. So b raised to negative 3 is equal to 1 over b raised to 3, right? And then if we isolate also b raised to negative 5 on the denominator, so that would be 1 divided by b raised to negative 5. This is equal to b raised to 5. Okay, so again, this is from the negative exponent rule. Okay, so we say if we combine the two, then we have b raised to 5 divided by b raised to 3. Okay? And this is just equivalent to b squared. Okay? And later on, we'll check if this is the case for this expression here. Okay? So we'll check later on. Then lastly, for c's, we have c raised to 5 minus 5. Again, this is from the quotient rule, right? Okay. Then let's simplify this. Negative 28 divided by 7. That would be negative 4, right? And then we have here a raised to the power of 6 minus 11. That's a raised to negative, or a raised to the power of negative 5. And then we have here b raised to, so this one, we have here negative 3 minus negative 5. So negative, negative, that would result to plus 5, right? So negative 3 plus 5, that's positive 2. So b squared, okay? So we'll get the same result if we convert them first to positive exponents, right? So it depends on you, on how you simplify this one. But either way, we'll arrive at the same result, right? And then c raised to 5 minus 5, that's c raised to the power of 0, right? And c raised to the power of 0, I mean, any number raised to the power of 0, as long as the number is non-zero. So again, any non-zero real number divided by, I mean, any non-zero real number raised to the power of 0, that would be 1, okay? So we have 1 here, all right? Then, again, we are required to express them in positive exponents. So we now have negative 4, negative the value of 4 times b squared, and then divided by a raised to the power of 5. Okay? All right. So next we have, all right, so we have two groups of factors. First one, we have 2 times x raised to the power of 4 times y raised to the power of 3 all over quantity 3 times z raised to the power of negative 3, and then raised to the power of negative 2, okay? And then second group of factors we have here, quantity 3, z raised to the power of 7, and then raised to the power of 2, all over 6 times x times y raised to the power of 6, okay? So again, let's group together the constant values. But first, let's deal with those expressions containing parentheses first, okay? So those with grouping symbols, we deal with them first. All right. So we have here, just copy the numerator, 2x raised to the power of 4, y cubed. And then this one, we apply power rule, right? So, I mean, distributive property in this case. So we distribute negative 2. So we have here 3 raised to negative 2. And then z raised to the power of negative 3 times negative 2. So that would be positive 6, right? And then times, on the numerator, we have here 3, again, distributive property. So 3 squared, and then z raised to the power of 7 times 2, that would be 14, right? And then all over 6 times x times y raised to the power of 6, okay? And then now let's group together the constants, okay? So we have here 2, right? And then this one, on the denominator, 3 raised to negative 2. Let's convert this to positive exponent. So this will be transferred to the numerator because of the negative exponent rule. So that would be times 3 squared, which is 9, right? So let's simplify this one later on. And then, so we're done with the first group of factors. On the second group of factors, we have 3 squared again. So times 3 squared. And then this is all over 6, okay? So let's write 6 as 2 times 3. so that we can easily cancel out the common factors, right? And then all the variables we have here. We have here first x raised to the power of 4, and then y cubed, and then below we have z raised to the power of 6, and then going to the second group of factors, we have z raised to 14 on the numerator, and then on the denominator we have x and y raised to 6, right? So let's now simplify. So we can cancel out 2, and then we have here 3 squared is 3 times 3, right? So we cancel out one factor of 3. Okay, so we are now left with what? We are now left with 3 times 3 squared, right? So 3 times 3 squared. And then on the denominator, we are left with factor of 1. Okay. So on the variable side, we have here x raised to 4. That would be divided by x. So we have x cubed. Okay, so 4 minus 1, if you look at the exponents, 4 minus 1, that's 3. Okay, then we have here y cubed, then divided by y raised to the power of 6. So if we take the difference, that's 3 minus 6, so we get y raised to negative 3. So negative exponent rule, we write this on the denominator. So y cubed. Okay, and then for the z's, we have z raised to 14 divided by z raised to 6. So take the difference, 14 minus 6, that would be 8. So z raised to positive 8. Okay. Then that would be what? 3 times 3 squared. So 3 times 3 times 3, that would be 27. Right? And then x cubed times z raised to the power of 8 all over y cubed. Okay, so this is now the final answer. Next example. So we have here simplify and express in positive exponents this expression. 3 raised to the power of a plus 2 plus 4 quantity 3 raised to the power of a plus 1 plus 18 quantity 3 raised to the power of a minus 1. All right. So this is different from the previous two examples because in this case, we will be applying the rules backwards, if you will. Okay, so for example, in this case, we'll be using the product rule, right? So let's recall the product rule. If we have a product of a raised to the power of n and a raised to the power of m, this is equivalent to a raised to the power of n plus m, right? So we usually apply the rules in this direction, right? And then in this case, we'll be applying the rules from right to left. Okay, so as you can see here, we have, for example, if you focus on the first term, 3 raised to a plus 2, this is actually written in the form a raised to n plus m, right? So if we apply the product rule, we can write this as 3 raised to a, right, times 3 raised to the power of 2, or 3 squared. Okay, the same with 3 raised to the power of a plus 1. Okay, we can also write this as 3 raised to the power of a times 3 raised to the power of 1, or simply 3. Okay, and then also for this one, we have here 3 raised to the power of a minus 1. So we can express this as 3 raised to the power of a times 3 raised to the power of -1. Okay, and then if we apply negative exponent rule, then that would be 3 raised to the power of a, right, divided by 3. Okay, so let's plug in these equivalent expressions for our overall expression here. So we have here first term 3 raised to the power of a plus 2, which is equivalent to this expression. Okay, so let's just copy 3 raised to the power of a times 3 squared, or let's say, let's write it directly as 9. Okay, and then plus 4 times, so we have here 3 raised to the power of a plus 1, so let's copy this one, times 3 raised to a, 3 raised to the power of a times 3, right, plus 18 times, and then we have here, or let's write this as a parenthesis for convenience. So that would be what? 3 raised to the power of a divided by 3. Okay? And then, if you notice, there is actually a common factor between the 3 terms. And that would be 3 raised to the power of a, right? 3 raised to the power of a for the 3 terms. So we can factor out 3 raised to the power of a, and then we'll simplify the remaining constants. Okay, so let's see. Factoring out 3 raised to the power of a, all right, and then we are left with, for the first term, we are left with 9 plus, so we have here, on the second term, we are left with what? 4 times 3, right? Because we factored out 3 raised to the power of a. So 4 times 3, that would be 12. Okay? Plus, so on the last term, we factored out 3 raised to the power of a. So we are left with 18 times 1/3, right? Or 18 divided by 3, which is 6, right? So we now have everything in this, inside the parentheses, they are constant values, so we can just simply combine them, right? Using the indicated operation. In this case, we have plus, so 9 plus 12 plus 6. Okay, so 3 raised to the power of a, that would be what? 9 plus 12, that would be 21, right? Plus 6, that would be 27. Okay, and then we can simplify this further. 27 is what? 27 is 3 cubed, right? Or 3 raised to the power of 3. 3 times 3 is 9, times 3, 27. Okay, and then we now have product of two exponential expressions of the same base. So what do? We take the sum of the exponents. So that would be 3 raised to a, or raised to the power of a, plus 3. Okay, so this is now the simplified version, if you will, simplified version of this expression.